Hello everyone, and this is the video about Super Dynamic Lighting shader and the update for this shader. And here I've added some shadow mapping that wasn't presented here before. And also I've added additional ways of doing the diffuse shading and specular reflectivity. So we have this result of kind of imitation of skin surface, skin material. So this is the MetaHuman mesh. I've exported from Unreal Engine, and also the textures are from there. So we could see here there is the list of textures that I've exported. So we have this face, color, we have the cavity map, which probably don't use. I'm not using it here. Then there is the roughness. The roughness is used as the art channel for specularity, for this Cook Torrance shading. Specular reflection, so I think that is used. Then there is eyelashes, which contains the alpha channel, so that we see that eyelashes are actually here. If we look at the geometry, so the geometry itself, it's very dark, but you can see that this geometry is just the polygons. So we have this alpha masking to make it looks like lashes. But without a good anti-aliasing enabled on the driver side, we can't see it very well, so there is a lot of jittering here. Probably I can force some anti-aliasing from the video card side on the driver side and make it look better, especially on some kind of anisotropic or multi-sampling filtering we have on video card on the video side. And then the normal map as well, which used here, you can see there is the factor, the visible micro details of the skin, lips, and then some basic mask that I've used for hair, but this is just to have a little bit lookish like a hair, but it's not a real shader that I wrote for hair, so it's just to be here. In addition, there is also a post-processing with enable ambient occlusion. So this is the filter which adding some micro shadowing on the surface. And then there is a little bit of color correction we have here. And the vignetting to have this kind of film effect. Yeah, more realistic camera looking. So what we have here is something that I'm going to go step by step in this video to show how the setup is done. And that's the idea. And also you can see that all textures are exported in DDS format. So basically this sometimes helps to more quicker loading into the memory in MotionBuilder. And also DDS is the only format which could contain bitmaps and can be used by the MotionBuilder side. Yeah, so let's start. So that will be our goal. I'm going to go into the new scene. And let me open the Unreal Engine now. So we have here a loaded MetaHuman. And we have here this Hadley face mesh. So this is the model that I started with. And it also contains some textures. So we don't need the load levels, which is level of details, so we don't need this. So I'm going to export only this mesh, and I can do it with the context menu, asset, actions, and we say export. So then I go to the face mesh, and that will be my start point right now. And then we have this big export options. I don't need any kind of collision mesh, etc., and just export the mesh as it is. And then every texture, which is the main texture like face normal, I'm doing the same as the asset actions export. And then from this list, I pick the DDS. So I already have this map exported. There I have no changes to this map, so I'm going to keep it as it is. And now I can go to MotionBuilder to open this face mesh here. And let's start. So this is what we have by default. And if we select the mesh and go, there is the big list of materials we have here presented. So the first one had synthesize. I think this one is actually belong to the main part of the face. So it's the main surface we have here. So this is something we will deal is in order to load the textures itself. So I'm going to open the folder with the textures that I have. So it's this. And then I'm going to drag and drop into my scene. I will need the color texture, definitely. So I'm going to add the scene. Then I need the normal. And also I'm going to add the scene. Roughness, which is used for specularity. And that's it for now. Maybe eyelashes will also will need eyelashes. Okay, let's add them. When we have these textures, we can go back to material. So I'm using these focus buttons to quickly navigate between material and mesh, which is very convenient. So I'm going back to diffuse and I'm going to add the color map here. Yeah, so we will have this color map. So we see that this is the default shader we have in MotionBuilder without having connected anything. To connect the normal map, we need to enable the advanced mode. And in advanced mode, we have this the checkbox we have presented. So let me put the navigator. Let me put it here to be more visible. So we have this advanced mode, have to enable it, and in that case we can have access to the normal map, and I can assign the normal map here as well. So you see, once we connect the material and texture, they're all presented into this focus and filtering, and that's give you a very quick way to jump between different types of assets. So now let's go back to our asset browser and would like to have the light here. So that will be our main main kind of sunlight, main directional light. So we need to change type for having this infinite light. And let's see how it looks like. Yeah. So this is the default shading we have here. And we could have some additional light as the backlight. So let's go to asset and add some additional like kind of backlight here. Yeah. So yeah, we can go further and make like a more studio kind of lighting setup. But for now, for test, I think it's fine. So what I'm going to show here is how to actually cast shadows. So to start with, we need to go to the shaders and find here. So let me show the list. There will be clear listening of the names presented. We have super dynamic lighting here. I'm going drag and drop and assign to our face mesh. So now you see that we have also the normal map quite visible, all the micro details. So they are so visible, they're even shimmering. So we probably could load down a little bit visibility of this normal map. So we could have it in material of our mesh. So if we go back to our main material and we have here a factor of using the bump map or normal map, so we can load down. I'm using the right mouse button, by the way, because this helps to scroll the value slower. So if you scroll with the left mouse button, you have the bigger step. If you scroll with the right mouse button, you have the smaller step. So we could make it less shimmering effect, but still to have this all micro details presented. So now we have default Phong specular reflectivity, you see here on the surface. And in additional, we have support for 3 ways of specular reflectivity and 2 ways of diffuse shading right now. So for diffuse shading, there is the way to, so how to switch them. There is no these options in the standard material. So we need to add some custom properties that will be used by the super dynamic lighting shader. And I wrote a script to create these properties on the selected material. And there is also some custom properties for the light. So in case you have selected some light model, it will create the needed custom properties to control the light behavior. So what I'm going to do right now, I'm going to, as my material is already selected, I'm going to run the script here. And I'm going to properties now. And in the properties, we could see there are new custom properties presented. So this new custom properties is the diffuse type, which is 0. If we assign 1, it will be ordinary diffuse shading. And you see the difference here. So if I switch back to 0, so the phone light is, it goes more in a dark, so it has less diffused effect kind of. And this one emulates of the light having this kind of thin layer of skin, so that lights emerge and diffuse more in the surface. So I think that's suited much better for the skin behavior, for the skin surface. And for the specular type, so the the 0 value referred to the phone specular reflectivity, which is default one. And that could be suited well for some kind of surfaces like plastic, for example. But then if you have some metalness, you can put it 1. So that will be anisotropic distribution of reflectivity, specular reflectivity, which is more like a metalness look. So for see the result of this, we need to increase the roughness for X and Y, because the anisotropic itself is not distributing in the all X and Y direction, so it has just one direction distribution. So we see that. Let's put it, yeah, so now we see that this distribution, now we have this line, so it's more like a metalness effect we have here. So very wide, not wide, but it's a narrow but very long specular cast we have here. And then if we put value 2, then this will emulating of the, it's a Cook torrents, so it's the distribution of specularity, which will suit it better for the skin. But we need to define a map, like this kind of roughness map. Instead of setting up one parameter, we could define a map on which areas we will have less, more or less roughness. And for doing that, we need to go to this specularity that we have and assign the roughness face map, sorry. And in that case, you will see that we have now reflection zone in front of a face, and yeah, this distributed in a much more interesting way to have the effect of a face material. So let's continue on our scene setup. And in order to not have this result of shading overbrighted or kind of washed out, we could do conversion between sRGB and linear color space. And for doing that, we need to go to our shader. So where is our shader located? I probably have to go to default layout. Okay. And now I'm going to choose the shader. The shader, it's connected to the face. So this is super dynamic lighting shader I have. And if I go to properties, we have here checkbox to switch to sRGB, and then back to linear space. So this is kind of gamma correction we do to our textures. And yeah, that could look more realistic. We also could emulate the backlight by using the rim lighting we have on our super dynamic lighting shader. In our case, we just simulate everything with the light, so it's fine. Now about the shadow. To make it work, we have to assign our lights as the affecting lights list. So by default, if you don't have in your super dynamic lighting shader this list, any light assigned to this list, then basically the scene lights will be used. So the whole list of lights you have in your scene. But in our case, we need to have this local list of lights in order to make it work. But basically we pick the same that we have presented in the system. And then we also need to define a list of casters so that we will give the system some understanding which light is going to cast a shadow and which mesh is going to cast the shadow. So this is our mesh, and we see now that we have this shadow. So this shadow is very, very sharp. That's because we have this 2K resolution, and for infinite light, the area of shadowing is computed on the, so by default, if there is nothing assigned on the light, I mean the bounding box, then the shadowing area will be like the frustum area for projected shadow map will be computed out of the world bounding box. So what does it mean? That if we have some additional object in the scene, like this cube, if I move this cube somewhere, let's say here, or even far away, you see that now it's a more shadow looking, a soft edge. It's because all this area now is used for 2K resolution to render into the shadow map. So basically that's decrease the quality. So you change the quality, changing the bounding box of the scene. So, but we can control this, because if you have your virtual character, and virtual character is walking around in the environment, and you have your camera attention to the face, you probably would like to have the same result, the same cast of the shadow, the same quality that you set it up, and to take control of it, right? So we could have the same cube. I will make it like a wire rendering, and I will put it around the face like this. So at the moment, the infinite light support only one set of textures, but my idea is to have a look at this bounding boxes and to have the logic so that how many bounding boxes you have, that many textures will be rendered. So in that case, for example, if we have the character and we want to have a correct, nice, good looking shadow with the details on the face, we have one texture, one bounding box. And then for the rest of the character, we could have another bounding box. And that basically could help to control the quality of each element and distribute the projected, like let's say 2K or 4K characters. So it's a technique for sunlighting in the rendering called cascade slides, which automatically, when you have perspective, it's automatically do a setup of the 3 or 4 frustum volumes based on the distance to the camera. But in this case, I didn't implement cascaded lights, but with the bounding boxes, you could emulate the way how cascaded lights works. So basically, you can put needed bounding boxes in front of a camera and have the same effect, but just you need a little bit of manual setup. All right, so let's go back to our shadowing and this bounding box. In order to set it up, we need to select our infinite light, and there is no properties by default which could do this control. So we need to go to our editor and the script for creating light and material properties, and run it again with the select light. So in that case, we have, first of all, we have the checkbox to control if this light is going to cast specularity. So you see there is the specular effect for face turning on and off. So there is a really big difference. In general, there is the flag to control if this light is going to cast shadows or cast the lighting on our mesh at all. And then the bounding box is something that we would like to choose from the list here. Yeah, so I need to, I can probably just drag and drop the cube into this list. And now, once I did this, now I have this bounding box which control the quality and control the area on which my shadow will be casted. So the frustum of the projected shadow map. So this is pretty cool, I think. We see also lashes. Would be nice to assign transparency for them so that they will not be visible as the polygons, but we could cut it and see as the lashes itself. So in order to do that, we need to go back to materials and find here, there should be some lash material, I think eyelash lower. And then in transparency channel, we could assign our eyelashes and probably put some color. Which color we want? Maybe some, just a black eyelashes. So we see them here. All right. So this is our shadow we have here. This is our eyelashes shadow. This is the shading we assigned. So I think in general, this is the main, I covered the main features that I've added. And additional setup we could do here is post-processing. So definitely, we could do some micro shadowing, like ambient occlusion. So in order to do post-processing, we need to go to shading elements and drag and drop post-processing into the scene. And then also post-processing only applied in the camera view, not in perspective. So that we need to drag and drop camera and set up some camera view here. And also for camera view, we could change the field of view to have a more portrait kind of projection. And then in the post-processing, if I go to properties, we could turn on the screen space ambient occlusion and turn on activate the whole post-processing. So we see now we have this micro shadowing additional applied. If there is a need, you can tweak the properties of the ambient occlusion as well. And then what else could give more realistic result? We can add vignetting, probably field grain to have kind of simulation of the film capture. And then there's color correction if you would like to do some, and the depth of field. And it also, in some cases, it could give an effect of more realistic, and you can control the target point, you can control the distance and behavior of depth of field as well. Yeah, so I think that's it for now. That was an idea to show some features I've added to the super dynamic lighting shader, and in general the way how you can set up a more high quality render inside the MotionBuilder for previewing. I think at the end, I would like to add one detail that in this particular face we have here, maybe this shadow map I can just hide. So this cube, hide the selection. So in this particular case, we have face mesh without any blend shapes. But in general, in MotionBuilder, if you would like to do the live performance, and the most quickest and easiest way is using ARKit. So this is ARKit setup of blend shapes that you could have on your face mesh. and have the live control over it. So the idea that we have one more extension, which is the solvers, and we have this calculate autonormal solver. So this is if we add this solver, and if we assign our face to this solver. So what it did, actually you can see here, even it has a little bit of changes of the shaping of the mesh. So we have visible more details on this mesh now. Maybe I can turn off the depth of field now. So you see that the more details are now visible, it's because what this solver is doing, it's in runtime, it's taking your mesh and normals and recalculate normals again based on your current shape, current geometry, deformed geometry. So this is very different what you see in MotionBuilder, because MotionBuilder, when you load a mesh, you have the static normals, and normals are used to calculate the shading based on your light setup, right? And your shader. So if you dynamically deform your normals, your light is reflecting that, your shading is reflecting that. So basically, when you have little blend shapes, by default in MotionBuilder, you will not feel, once your face is moving, you will not feel the change of the shape. It will be just the positioning of the vertices around. But if you recalculate the normals, you will feel the change of the shape. If there are some bulges, if there are some pulls and pushes on the surface of the face, so that could give you a little bit more realistic result, a better understanding how your facial animation looks like. So yeah, this is the solver that you can use to update your normals at runtime. Definitely this normal, it doesn't take into account any smoothing groups, anything like this. So it's just to smooth the mesh under some degree. So that means that it's more better fitted for like generalized uniform meshes, but for face it should be a good fit, especially if you have a clean geometry of your face. Should be a good fit. Yeah, I think that's all for now. Thank you for watching, and hope that is helpful to really find out how to use the new tools and how to render more interesting, more high quality looking models inside the MotionBuilder. Just check the documentation. I also reflected some notes there on the docs OpenMoBu org. And see you in next videos. Thank you, bye.